All right, class, Algebra 1, Lesson 38, simplifying expressions using greatest common factor, or GCF. Simplifying expressions that contain numbers often requires us to have a knowledge of prime numbers and factors. What you do want to remember is that a prime number is a whole number that is only divisible by itself and 1. So as we break these things down, that's what we want to look for. 2, you can only break that down 2 and 1, 5, 5 and 1, 13, 13 and 1, 19, 19 and 1, other prime numbers, and you really want to know your primes here. So 1, 3, 5, 7, 11, 13, 17, 19, those types of things, 23. Those primes are numbers that you're going to want to know, and really probably more so anything under 23 is going to be most of what you're going to work with. 2, 3, 5, 7, 11. You might deal with some 13s. I would say in most of my experience, 13 is the highest prime that you're probably going to need to break something down into. So a whole number, all whole numbers other than 1 that are not prime are composite numbers. Composite numbers have whole number factors other than 1 in the number itself. They can be written as a product of prime numbers, which is called prime factorization of a number, and that's going to be the big part of what we're looking at today. So like numbers like 4. 4 is broken up of 2 and 2. 6, 2 and 3. 8, 2 by 2 by 2 are the primes that make up the number 8. I'm trying to think if we just talked about like a random one. Let's say we said 256, for instance. And we wanted to break 256 down. I use, and what we'll probably see here a little later, is what is called the cake method. So I break it into an upside down division bar. Obviously, I didn't invent this, but I see that it's an even number. I'm going to divide it by 2. I'm going to get 128. Right, at this point, I got 2 and 64. All right, 64 would be what, 2 and 32. Okay, we got 2 and 16, 2 and 8, 2 and 4, 2 and 2. So we actually have 1, 2, 3, 4, 5, 6, 7, 8. Right, we'd have 2, 1, 2, 3. Sorry, brain's on autopilot. Okay, 2, 3, 4, 5, 1, 2, 1, 2, 3, 4, 5, 6, 7. Let's put another one on this end. So 256 equals 2, essentially, it'd be the same as 2 to the 8th. Okay, is the prime factorization of 256. I don't know if that helps you out or not. Fortunately, everything used up 2's in that. Okay. So several methods can be used to find the prime factorization of a number. The process requires breaking down the composite number until the factors are all prime numbers. We don't want any other composites because a composite can always be broken down. The prime factorization for the number 24 can be found in at least 3 different ways. And you can see this in your book on page 236. Let me just I can kind of outline it here a little bit. One method where they do 24, at least I'll say the first one, looks like 2 times 12. Of course, we can take 12, right? Now would be 2 times 6. Well, we can take 6 and get 2 times 3. Okay, so it looks like that. It's kind of an expanded form. Okay. And I don't know that they've given a name for that exactly, but that's just one view of it. Then we can kind of do, I guess, what you would call the branch method, right? We'll kind of break it down like this. I think this is maybe what more people are familiar with or grew up with. You know, this is 2 and 2. This is 2 and 3, right? And those are my prime factors. And then there's finally what I've grown up using or kind of started to use, which is this kind of what we call cake method. It looks like an upside down kind of cake tier where you're getting 2 and 12, 2 and 6, 2 and 3, and you're just kind of looking at it like that. Okay, still wind up with 3 2's and a 3. All right, it doesn't matter which method you use to find prime factorization. A final product does have to consist of only prime numbers. The factors are usually written in ascending order. So smallest numbers first, so in our case 2 times 2 times 2 times 3. Okay. Prime factorization can be used when determining the greatest common factor of monomials. This gets a little bit more interesting as we throw in variables with exponents, and which is the product of the greatest integer that divides without a remainder into the coefficients and the greatest power of each variable that divides without a remainder into each term. It's really wordy. Hopefully it'll make more sense when we work out some questions. Finding the greatest common factor means finding the largest monomial that divides without a remainder into each term of a polynomial. So what will go into everything? Finding the greatest common factor of a polynomial allows you to factor. I should just go in there and retype that, but short on time here. Factor it and write the polynomial as a product of, let's see, that's what I get for not, see, move that t over, instead of the sum or difference of monomials. Factoring a polynomial is the inverse of the distributive property. Using the distributive property is the opposite. It undoes the factoring of the greatest common factor. Fractions can be simplified if the numerator and denominator contain common factors. That's because the operations of multiplication and division undo each other. So if you see something like 4/10, right, I can divide both those numbers by the same number. They share the ability to be divided by 2, which gives me 2/5, 8/4. Both those numbers will divide by 2, so give me 2 over 1, and finally I can get 2 out of that. An algebraic fraction, if I had 4x over 10x, that can still be divided by 2, giving me 2x over 5, or in the case of 8x over 4, 2x over 1, which results in 2x. So we want to notice that there's no addition or subtraction involved in the fractions above. Simplifying fractions with addition or subtraction in the numerator follows similar rules to adding or subtracting numeric fractions. A fraction can only be simplified if the numerator and denominator do have common factors. Okay, it's a lot of reading. Let's try to do some actual work here, if at all possible. All right, so number 1, which choice shows the prime factorization of 225? All right, well, I'm going to come back to my little tree here, and I'm going to do it like this. I should see right off the bat, right, I can divide that by 5. Okay, 225 divided by 5. Okay, is 45. 45, I know I can divide by 5, which is 9. 9, I know I can break down into 3 and 3. So I'm looking for, and I want to go in order, so I know that's 3 times 3 times 5 times 5. We want to go in ascending order, so from the bottom up. So I should get A as an answer there. Hopefully that makes sense. Okay. All right, find the greatest common factor here of negative 25 x to the 4th minus 5x to the 3rd minus 20x squared. So we're looking for something that will go into every single term. So let's try this. Let's look at 25. I know it says negative 25, but that would break down into, let's say, negative 5 and 5, right? We got negative 5. That'll break down into negative 5 and 1. We have negative 20. That'll break down into, let's see, negative 5 and 4. Okay? And you could change this a little bit. I mean, you could easily take that negative off that 5 and give it with the 1. And with this negative right here, give that to the 4, and what we would see is that they all share a 5. They all have a 5 that we could pull out. Okay? So let's kind of hold that off to the side here for a second. Now, they all have, let's see, they all have something else. Let's, this first one has x times x times x times x. It has 4 x's. This one has 3 x's. It's x to the 3rd, and this one has 2 x's. So the most that all of them have, they all have 1, 2, 1, 2, 1, 2. So they all have 2x's. So 2x's, right, is equivalent to x squared. So 5x squared is the greatest common factor. They all have a 5. And arguably, you could say that they all have a negative 5 that we could take out. It really doesn't matter whether you say negative 5x squared or 5x squared. We could take both out of everything. But that's the biggest thing that we can take out of everything. And that may be the point that they're trying to say, is that 5 is greater than negative 5. So we would take out 5 instead of negative 5 and get 5x squared. Hopefully that makes sense to you. Okay. All right. Number 3. All right. Here, 525. If I want to know what's going to go next to this right here, I'm looking at taking 525 and dividing it by 21. Okay. So 525 divided by 21 is 25. Okay, 21 times 2 is 42. Okay, that left me with nothing there, it's just 10, which left me with 105, right, and there's where my 5 came from. So this should be 25, okay? All right, what can we break 21 down to? Well, probably 3 and 7, and 25 would break down into 5 and 5. So let's see. That's wrong. And let's see. This is right. That'll work. That'll work. Should get something like that. Let's see if there's any reason why C would not be our answer. Okay, we can tell B is way wrong, D is way wrong, so yeah, C is our answer. All right, let's come down here. Here, you're kind of seeing that cake method done. Find the prime factorization of 126 using what they call a step diagram. I would divide by 2, right? Dividing by 2. 126, I think that would be 63. 63. That looks like that probably divide by 3. 63 divided by 3 would be 21. 21 will divide by 7 and leave me with a final prime factorization of 3. So in the end, I should have 3 times 3, 2 times 3 times 3 times 7. 2 times 3 times 3 times 7. C looks to be my answer. Okay? So whatever your last one is, that's also part of it. Okay? And this prime factorization is going to come in handy later whenever we start dealing with, or you start dealing with, whether it's in this class or start working with trying to simplify radicals. We'll need to do greatest common factor, prime factorization over and over. So here we're going to take 10g to the third. So I've got 10g to the third. 10 breaks down into 2 and 5. And we'd get g times g times g. Okay. Let's see. 25. 25 g to the fourth. Okay, that's going to be 5 times 5 times g times g times g times g. Okay, so we're looking at what they have in common and the most that they have in common. Well, they have 1 5 in common, and they have 3 g's in common. That's the most g's I can take out of all of them. So I should be getting 5g cubed is my greatest common factor. That's the most I can take from anything there. All right, let's keep going. 6, factor the polynomial. Okay. All right, again, we're going to take out what the most that we can take out. 3 is already prime. So let's try to think of a way to show this. So we've got 3r to the fourth t. The prime factorization of that is 1 and 3 times r times r times r times r times t. Okay, that's expanded. That's what we're getting there. All right, then if we have negative 6 r cubed t, okay, that would give me something like negative 2, 3, okay, times r times r times r times t. So we want to look at what we can take from everything. Well, we can take a 3 here and a 3 here. We can take at most 3 r's from everything and 1 t. So what I could take from this is I can get 3r cubed t, and whatever I don't use is left inside. So I didn't use this 1. Okay, I didn't use that 1, and I didn't use this r. So that's 1r or r. I didn't use this negative 2. Negative 2, and that should be about all that's left. And I believe if you look, you're going to get 3r cubed t, r minus 2, c is my answer. And we work with this even in Algebra 3. So if you start figuring this stuff out now, how to do this, you're going to be miles ahead if you'll hold on to this and be able to apply it then. All right. Okay, number 7. Find the greatest common factor of the set. 64, 16n squared, 32n, and 48n cubed. Well, just kind of as a heads up, notice that 64 doesn't have an n. So n can't be one of my greatest. I can't even include n as a greatest common factor because it doesn't even have an n in the set of 64. So we can take 64, and that's going to be 2, and I always like to start with a prime. You could know that you could do 8 and 8, but then I'm going to have to break that 8 down again. So we would get 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. Okay? 16, 2 and 8, 2 and 4, 2 and 2. 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. 48. That's 2 and 24. This is a little different. 2 and 12, 2 and 6, 2 and 3. Okay? So our 64 has 1, 2, 3, 4, 5, 6 2s, or 2 to the 6th. 16 has 1, 2, 3, 4. That's 2 to the 4th. 1, 2, 3, 4, 5. 32 has 2 to the 5th. Okay. And 48, 1, 2, 3, 4, has 2 to the 4th times 3. So we have to go with the smallest one. And the smallest one is 2 to the 4th. Let's see. And they're looking for the straight number, that's just a straight up, what's the biggest number that will go into both. So 2 to the 4th equals 16, right? That's what we see here. 16 is 2 to the 4th, and so 16 is the biggest number that will go into 64, that'll go into 16, that'll go into 32, and go into 48. It's the biggest number that will go into all 4 of those, and because 64 doesn't have an n, we didn't even break those down. All right, 8. Factor 7a squared b to the 5th minus 7a to the 4th b cubed. Well, they both have a 7, so we can factor 7 out of each of them. And as far as our variables go, they both have an a, but we can only take the a with the least number of exponents. So I can take out an a squared. And the other one has b. They both have b's, but the second one has the smallest set of b's, which has b cubed. So what we have to do is go in here. All right, well 7 times 1 is 7, so we've got that. But we left here, we left two b's behind, so that's going to be b squared there. We got to bring in this minus, and here we left two a's behind, so we'd have a squared. And what I want to be able to do to double check my answer is to see if I've distributed all of this back into here and here, would I get this answer again? And if the answer is yes, then I know that I've factored it completely. So I'm going to check my answer here, 7a squared b cubed. And actually, we can take this a step further, okay, before we move on, is that this can be factored down again. Because both of these are perfect squares and we see subtraction, right, what we have is what we call a sum difference. So we have b minus a times b plus a. And just so you see how that works, b times b is b squared. We're going to FOIL here. B times a is positive ab. Negative a times b is negative ab. And negative a times positive a is negative a squared. These are going to cancel out, leaving me with b squared minus a squared. So our final answer here is 7a squared b cubed times b minus a times b plus a. Okay, and that might be the hardest question that you see in this lesson. So if you see a question like this, you get stuck on something like this, shoot me an email, ask me in class, and I'll try to help you out with it. All right, find the prime factorization of 44. All right, what can we divide 44 by? 2, because we end with an even number. 44 divided by 2 is 22. 22, we'll divide by 2, leaving me with 11. And, okay, we're left with 2 times 11. All right, all primes there. Okay. Let's see, let's check at this next one. Now I'm going to go back on this number 10. I'm going to do like I had done above. Hopefully this will help you out. I'm a little worried that you might have been confused by number 8. So let's take negative 16 x cubed y cubed z squared, and we're going to show it in completely expanded form. Okay, so we're going to get, let's start with negative 2. Let's see, negative 2, then we would get, I'm going to pull it off over here. Let's see, that would be negative 2 and 8, 2 and 4, 2 and 2. So we'd get negative 2 times 2 times 2 times 2. Okay, 2 to the 4th is 16. Times x times x times x times y times y times y times z times z. That's the complete expanded form. And now we're going to do the same thing for negative 4. Okay, well that's negative 2 and 2. Then we're going to get, this is x to the 5th, y squared. So times x times x times x times x times x times y times y. All right, what do they share in common? All right, we're looking for the greatest common factor, things that would go into both of them. Let's see. So, well, they do this a little differently, but here we've got negative 2 and 2. Okay, so we can take both of those. We're looking for, we can take out 3 x's and 3 x's. We can take out 2 y's because this only has 2 y's. And that set doesn't have any z's. They actually do, they don't even consider this as part of it. So if that's the case, then we really wouldn't include this, which means we wouldn't include that there. We could have gone and picked out those 2's and 2's. So anyway, in any case, we get 4 x cubed y squared is the greatest common factor of those two terms. Okay? So let's apply that principle to number 11. again, I think that you have the least possibility of making a mistake if you show things in expanded form. That's my experience with dealing with it in Algebra 3. If we have negative 15, c d to the fourth, okay? Let's look at the expanded form of this. Let's be negative 3 and 5, okay? Negative 3, 5 times c times d times d times d times d. Right, we're not going to even consider that. That's part of the operation. So we're going to look at 20 c cubed d squared. Okay, so let's see, we would get here, we should get 2 times 5. Okay, times c times c times c times d times d. All right, what do they share? Well, they share this 5. What else do they share? Well, they share this c. And what else do they share? Well, they share these two d's there. So looking at what they share, okay, we're going to pull out what they share. So they share 5c d squared. Okay, what goes on the left? All right, well, on the left, we're going to start with negative 3, okay, d squared. So that's what's left. Okay, we're going to throw in that minus that we see there, minus 4, 2 times 2 is 4, c squared. Check my answer key here. 5cd squared times negative 3d squared minus 4c squared. This is our answer. Okay, I think that's the end. I think the rest of this is answer key stuff. So if you have questions, I hope some of that made sense. Some may be the long way of doing it, but I want to make sure that you got your heads wrapped around it before I try to tell you how to real quick get straight to the answer. I want to know that you can get there the right way every time. All right, I'm going to let you guys get to work.